Hello everyone. We've been working on our final projects in this class. So far, we've designed our projects, we've collected the data in the field, we are now analyzing the data and developing our stories, and now we're arriving in the most important part of, arguably the most important part, the writing of our final scientific paper. So, this cartoon is the antithesis of what we would like to do. We actually want to make our results clear, transparent, and easy to understand and easy to read. We've done the work, got the results. It doesn't matter how we're judged by how we got the results. So, producing our professional scientific paper. We're in the last phase of the process of this professional process, and arguably, as I said before, the most important part. So, number one, do not turn in a scattered first draft that is not well written, does not flow well, and does not have a good narrative story to it. Good writing takes time, many drafts, not just several drafts. Finish a draft, leave it for a few days or a few hours, then read it critically again. That means you need to start writing early if you're going to give it a few times so that you can revisit it. The writing should be concise, but engaging and easy to follow. It shouldn't be this flowery language. We're going here for minimalistic style in writing that's clear and engaging. We're not looking for this really flowery language. The reader should be able to summarize your paper in several sentences, so it should be clear. You should be able to summarize your paper. You should be able to sum it up in 2 to 3 sentences. The elevator speech. You guys have all heard of the elevator speech. You're on an elevator with someone, you have a short ride to tell them what you're doing, how you're doing it, and so that it comes across clear and impressive. That's the elevator speech. You should be able to do the same with your final projects. So the steps of writing. So we have 5 steps listed here: the pre-writing, writing, revision, editing, and proofreading stage. So I think that you guys are all hopefully in the writing phase at this point. So you've written your methods, you've started to write your introduction, you've started getting your results together, making paragraph plans, and working on it. So we should have our notes all scribbled out. We should know what's going on. And soon we should be entering this revision phase. You work on the content, making sure you have a good paragraph plan. You're focused, you keep your focus on your main purpose, the communication, the reasoning, and presenting your work clearly. Ask for feedback with your other group members, or ask for feedback from me. I'm more than happy to look at initial drafts, but not 2 days before the final paper is done. The editing phase becomes the fine combing phase, checking all the data for accuracy, reviewing the grammatical, mechanical, and usage errors, making sure commas are right, semicolons are right, the literature cited is correct. And then finally, the last phase is the proofreading phase, which seems to drag on, but print it out, go through it, look for the errors, redo any small sections that you need to. So our final papers in this course should read like any scientific paper. We should have an abstract, a summary, an introduction, where the last paragraph should be about the objectives and your hypotheses. We should have the methods, followed by the results, the discussions, and then within the discussion should be a short conclusion right at the end, and it should really relate back to the objectives you defined in the last paragraph of the introduction and your conclusions about those. So writing science, think of the OCAR, the opening. When we start in the introduction, the opening, what is the larger context of our problem? What background do readers need to know? And sometimes you need to think really clearly about this. And then what are the current knowledge gaps that we are filling in here? So then we propose at the end of the introduction the challenge. What are the specific hypotheses, questions, goals of your final project? The action part of this is how did you address the challenge and what did you find, your results? And then the resolution to the OCAR is what did you learn from your work? So this is the discussion. How is your work, how is what you learned contributed to the broader understanding? And it looks a bit like this. We start broad, the opening, the introduction, to introduce the topic and background. Then the challenge is there. It gets down to the specific questions and how you're going to address the challenge. The action is what you did and what you found your results. The discussion then is what it means, and the resolution provides is this place for the conclusions where we talk about the take-home message. So this familiar structure makes it easier for us to read scientific papers. So writing science is very difficult. Planning a narrative is very difficult, at least in my opinion. I was never a natural writer. I still am not a natural writer, and it takes a lot of work for me to produce a scientific paper. So think of the overall arch of the paper that encompasses the whole paper. Then you have the arch for the individual sections, the introduction section, and they should be complete arcs. We should make them all the way across the arc, and that the sentences line up so that we have complete sections, complete arcs from the beginning to the endings, so that it's a paper that's easier to follow. So below is the complete linked arcs. And this is how we should like these to flow. I usually do this working on paragraph plans, trying to start my arc from the beginning to the middle and then build those into sections and then into the paper. And I'm often guilty of this. When I first write drafts, I end up with these incomplete arcs. Ideas that are discussed in multiple places but not clearly brought from beginning to end. And this is where I really work on the revisions and planning and thinking about the arc from beginning to end. Am I going from the beginning of I have arcs in the sentence, I have arcs in the paragraph, and then arcs in the sections that make it easier to put these sections together. So the introduction. We need context. So the relevant background. Why is this interesting? Lead into your research. What do we know about this topic and what do we not know? And where do our knowledge gaps exist? Then the very last part of that is the objective. So these should sort of go in order. The objective should seem obvious based on the context you provided us, the need of what we need to know, making the objective almost flow right out. So state the questions, the objectives, and hypothesis, and that should be at the end of the introduction. So the challenge is at the end of the introduction, this part. Include, and this is the challenge, so include our broad goal, our question for the research, why are we doing this? Then you can get more specific. To learn X, we did Y. See how here it flows here with thus we recorded Bromus tectorum, native perennial grass, and shrub abundance across the chronosequence of fire determine if independent of physical disturbance could increase the degree of invasion at this site. So this should fall smoothly at the end. Here's another example. We collected tree ring data to reconstruct a paleo-ecological reference of pre- and post-European fire history. Here's another example of putting these objectives in to determine how vegetation recovery varies with landscape, island geomorphological characteristics, and local environmental characteristics. So to support these objectives, we address 3 specific questions. So read through these paragraphs and see how that they flow. They start with our objectives, where to examine, and then they get to the action of exactly how it was done and asking of the questions. To evaluate if the action, so we're evaluating how and why fire-climate relationships varied in the most fire-prone regions. So the introduction, again, starts broad. It's an upside-down triangle, and it ends specific. So one example where we visited sites in class might be, we're going to write about the effects of road decommissioning on the plant biodiversity in highlight. So if I'm planning my introduction, I want to start general road ecology. How do roads affect biodiversity? What do we know about when they're decommissioned, providing us context? And then about how it affects biodiversity, slightly more specific. Now, we've also identified the knowledge gap in this section by saying, okay, we actually don't know very much about the effects of road decommissioning practices on plant biodiversity, which leads smoothly into our objectives and then into our hypotheses. So for your papers, I would like 1.5 pages of if it's 1.5 spaced, introduction where we start with this plan. And that would be more if it's doubled. For peer-reviewed journal articles, I really try to be at about 3 pages double spaced for the introduction. So the methods are precise details needed to repeat the study, the where, how, with what, how many times, and the analysis techniques. That's the statistical analysis techniques. And it should not be, oh, we just use R to do this. It should explain the exact techniques. We fitted generalized linear models. We use ordination techniques to examine whether plant species composition varied. Present the how if you have several in order that makes the most ecological sense. For example, large to small, simple to complex tasks. This may not be in the order you actually did the work, but this should also be the methods, the order of the methods should mirror the order of the results. Diagrams can help, but in this case it may not be so necessary. You could make them into appendices that showed sampling diagrams or gave a list of georeference points of where you sampled, for example. This should be I would say 1.5 to 2 pages, double spaced. Yeah, that sounds about right. So the results. What are the results? This is where you write the results without interpretation. Objectively present your key results. Start simple in the results and build to the more complicated results. Report the ecology, not the statistics. Don't say the p-value of X was this, so there was a difference in X and Y. Report the ecology. The plant species richness of burned plots differed from those of unburned plots in the first season following fire. Then in parentheses, the test statistic that you use to support that assertion. Present your work in the same order as in the methods, making sure the logical flow that we can go back and forth, that the arcs aren't out of order and we know where we can find each one of these arcs, contributing to the readability. So I would say 3 to 8 pages, double spaced. Don't make graphics more than 1/3 of the page. Be conscious not to leave a bunch of white space and to also put in high resolution graphics. It's counterintuitive in R, but a lot of times as you shrink the graphic, making the graphic window more closed, you're building up your resolution, you're making that graphic a more appropriate size for your final paper. So here's a quick review. So should these statements belong in the results or the discussion? Richness was higher in the burned than unburned plots. I just used that example. That belongs in the results. Diversity may have differed due to possible nutrient differences after fire. That's interpretation. That belongs in the discussion. Other studies have also found a difference in richness between burned and unburned plots. that also belongs in the discussion because that's putting the results you found in context. Soil moisture was lower by 20% in the burned than in unburned plots. That belongs in the results. There's no interpretation. It's simply reporting that soil moisture was lower by 20% in the burned and unburned plots. And that's also written well. It's not saying the statistical difference between soil moisture was blah, blah, blah. It's actually reporting in active voice soil moisture was lower than 20%, was lowered by 20%. So this is one of the things that I think about a lot and I really like to think about, and it's what makes a good graphic. Because the graphic can tell the whole story. The figures provide a mechanism to communicate. Figures are strongest when the reader can look at them and see the obvious result in them. So you can test this. Give your figures to someone who doesn't know the exact story at hand and ask them, can they describe your results, the simple story, just by reading and looking at the figure captions. And captions are really important and should be also self-explanatory and should be standalone. You should be able to copy a figure out of a paper with its caption and understand nearly everything about that figure. So there's many different types of graphs. Scatter plots are good for continuous data and numeric data. On the left, we had Pinus contorta cover in response to species richness in different sites in Argentina and Chile and the USA. And then we have on the right a graphic from a paper about the germination of Verbascum thapsus mullen. And so can anyone see the obvious result there? Is the result obvious? The same goes for the left graphic. These are both presenting continuous forms of data. So can I hand you this graphic and you tell me the major differences between these? Box plots, we've talked about box plots. We've made box plots, I think, in all three of our homeworks. They're good for categorical explanatory variables with discrete levels, right? Factors. This is one where we have regions of the world on the x-axis and a continuous variable seed predation on the y-axis. The color coding helps here, the legend helps here, and we get an idea of the distribution of the data. Be creative, but the graphic should be informative and easy to follow. And my example of this is, who's read the book War and Peace? It's actually a brilliant book. It's about 1,000 pages long, I think, in translated English. And so it's a very laborious, long story to read. There's a lot to absorb, but it's basically about Napoleon there on the cover and his march to Russia. So we have this 1,000-page book, or we have this single graphic. This is a famous information graphic. It's often been referred to as one of the best information graphics produced, first best information graphics produced, and it brings 4 variables together into a 2-dimensional graph that's relatively simple. And so this is a figure, a carte figurative, made by Charles Minard. Minard, I know is his last name. I'm not sure of his first name. But this is the a sequence, a time series of and geographic distance of Napoleon's march into Russia in the 1812, then the Russian campaign in 1812 and 1813. It was drawn in Paris in November 1969. So War and Peace is essentially the same story about Napoleon's march into Russia. And this graphic tells a very detailed story about where Napoleon was, whether he was attacking or retreating, and the size of his army. So Kono on the left, the x-axis here is longitude. So we start at about minus 26 degrees. And you can see Kono on the left, Konau, is a city in Lithuania. The river there is when Napoleon on the left, the Niemen River is where Napoleon crossed the border. And he started with 422,000 troops, and he attacked his way to Moscow, which is on the right. So the width of the bar is his troop size. So he started with 442,000. When he got to Moscow, he had only 130,000, I believe. And then the black line here indicates Napoleon's retreat back across the river in Lithuania, where he was then captured near the border of East Germany and the Czech Republic. So he did a great job of bringing the four variables together in a two-dimensional graph. You can see Napoleon crossed in a similar area, and he left with 422,000 troops and arrived back across the border with less than 10,000. And just looking at that graphic paints a very vivid picture of what it must have been like to be a French soldier then. The bottom of the graphic here shows the temperatures in degrees throughout this campaign, and the dates are written in Roman numerals. And so I rewrote them a little bit. I redid the graphic in R showing the same attack retreat, taking his data and putting on some of the cities, a few of the more cities. Moscow was where he ended. But you can see the temperature as they left Russia during the winter of 1812-1813. So in October it was cold, but by the 7th of December or the early December, it was minus 30 degrees Celsius, which is getting close to minus 30 degrees Fahrenheit, or if not more. So you can see we've represented this whole Russian campaign in just one two-dimensional graphic. And then when you guys are writing your figure, put the figure caption below. Table titles go above, and it should be self-explanatory. So here's the notes, and I know I've mentioned this once, but this is something that many students do in their writing. In the main text, do not say table 1 is the species richness with square and circular nested plots. Tell the reader what is important. What are your results? When sampling with 1 meter squared square-shaped plots, we recorded X number of species per plot, and when we use circular plots, we recorded X number of species per plots. Another example below, species richness increased with increased sample area for both square and circular frames. So use the active voice. Don't say table 1 is just these results. That tells us absolutely nothing. So here's some examples of results. Straightforward, no discussing, no interpretation. Organized, one paragraph for the large scale, next paragraph for a smaller scale. Divide your paragraphs by your questions and your objectives at the end of the introduction. Figure reference and statistics go within parentheses. No way should they be leading the sentence. The sentence should be active about the results, and then you give the statistics and a figure reference so that we know where we can evaluate it or look at the figure ourselves. So the function of the discussion is to interpret your results in the context of what is known and your hypotheses. So, how did your results answer your hypothesis? How did your results compare with the findings of other studies? And you should sort of set up your discussion in that way. How did your results fit in the context of what you said you would do, and how did your results fit in the wider context of what we know? And when you're citing a reference, focus on the ideas, not the authors. That is, make the important statement, then cite the authors. And again, use the active voice but past tense, and focus on the ecology and not the statistics. Those go in the results. So the discussion is an upright triangle. It's a reverse of the introduction. And it's start specific about your results and then go broad. And it's in broad, especially for the conclusion section. End with the summary and conclusion of your work in the discussion, what we have learned about your topic, and how it's important. Restate simply the most important and basic finding in a positive manner. People often read this final paragraph, and this should be, 2 to 3 pages double spaced, I would suggest. And be sure you find literature and cite literature in your discussion and in your introduction. So here's a discussion example from the Cleland paper that we just showed the results for. And it's about native richness has the opposite relationship with non-native richness versus relative abundance. So they're restating native and non-native species richness were positively correlated when observed across community types from the scale. And they're saying this is consistent with the findings of past observational studies with the hypothesis that both groups respond in the same way. And then they're saying how their results fit in. The strong positive relationship between native and non-native richness across community types at the LTER extent supports the hypothesis that both native and non-native species richness are responding to environmental factors. So it's okay to restate the main result. You're comparing it with other studies. You're compared to your hypothesis and ecological hypothesis, and then you're discussing if your results are different, why could that be different? So the conclusion, state what we've learned from your work, not just that we learned something. These are where the main take-home points are and what the implications of it are. Don't add any new information here or don't add any new speculation here. So here's an example of a conclusion. Our work suggests that variability in climate and non-native climate factors can combine to alter links between climate and fire. And the northern Rockies may foreshadow how other regions in the western United States will respond to the fire deficit. And then your final concluding sentence, together this work highlights feedbacks among climate, fire, and vegetation. That is the take-home message. Here's another example of a conclusion. Because fire elevates deer mouse densities, this situation represents an unforeseen indirect effect of forest fires, and that disturbance mediated top-down effects on rodents on plant communities. So, we've talked about the introduction, the methods, the results, and the discussion. And in the beginning, I mentioned the abstract just briefly. And the abstract is usually what is written last or is refined last. I sometimes write it just to get in the beginning, I make a draft just to get myself oriented in how I think the narrative of the paper is going to flow. So writing the abstract is usually the last step. It's the most important section and probably the only section that many people will read. It should be 200 to 300 words. We should get in a sentence your aim, the location, the methods, brief methods description, the results, and the main conclusions. What's the key take home from your work? And that should fit in the last sentence. Here's an example of how abstracts are formatted for the Journal of Biogeography and that family of journals, Global Ecology and Biogeography and Diversity and Distributions. They basically lay out section by section so it's easy for the reader to find the aim, the location, the method, the results, and the main conclusion. If you guys would like to write your abstracts like this, that's perfectly fine with me, or you can write them in paragraph form without the headers aim, location, method, results, main conclusion. So I'll give you a final overview of your paper. Remember, you can work on your graphics together, especially those of you who have been in the same group. The discussion must be written on your own. It should be 1.5. You should make it 1.5 spaced, and that should fill 10 to 12 pages. approximately 4,000 to 6,000 words, not including your literature cited. And it doesn't matter to me how you format your references, APA style or MLA style for references, or you can mirror your favorite academic peer-reviewed journal, but be sure you include a literature cited section in your paper, and that will generally come last. Editing. If you guys should work on editing together, make a reviewing group and review each other's papers, trade papers. It's important professionally. I do it all the time. And I will be willing to scan your papers before they're due, but not just before the due date. And there's an error on this slide. Your papers are due by October the 7th, not the 9th. Email me or a draft of your paper or ask specific questions in the discussion. Thank you all for listening.